Everyone. I'm Bhupesh Goyal, Assistant Professor, Parul Institute of Technology, Faculty of Engineering Technology, Parul University. I welcome you all for the webinar on operational research, which is a need of today. We're having with us Mr. Amit Sarkar. He's currently working with the Intel Malaysia as Operation Research Engineer. He's having his master degree in Industrial Engineering and Operation Research from IIT Bombay, while he's having his bachelor's from Jadavpur University, Kolkata. For few time he was with us in Parul University as well. Now we organized this particular webinar on operation research under the banner of Institute of Engineers chapter, students chapter particularly. Institute of Engineers is a statutory body to promote and advance the engineering and technology established in 1920 and incorporated Royal Charter in 1935. It is the largest multidisciplinary professional body of engineers encompassing 15 engineering disciplines with the corporate members more than 2 lakhs and serving the nation more than 9 decades. Amit sir, I request you now to continue with the subject.
Okay. So first of all, thanks Parul University and especially Bhupesh sir for giving me opportunity to share my experience here. So today I'll be discussing one very interesting subject called operations research. So today's topic is operations research, the transformative interdisciplinary for 21st century. So why this is transformative, we'll see for 21st century, because in 20th century, its application was very limited due to non-powerful computers and all. So let's see what's inside. Okay, so next hour I'll be discussing these topics. Like I'll be discussing first the history of operation research. What is the origin of operation research? We'll see. Then some overview, some high-level overview of operation research. Then some applications of operation research. Then we'll go through some selected industry applications of OR, and we'll see some career opportunities for operation research professional. Okay, so history of operation research. It is said that operation research originated during World War II, while British military facing some difficulty. So they invited some scientists to study the strategic and tactical problem to improve airports and military operations for the country. So there was one scientist called Patrick Blackett. He led the operation research group. So first operation research problem was solved, like how to set time fuse bomb to be dropped from an fighter plane onto a submarine. So the story was like a German submarine found a way of spying British radar while diving before the bomb. So Patrick Blackett come up with a solution by using scientific research. So earlier, operation research was called scientific research. So he come up with a solution. Basically, he come up with the design of bomb cell. So that would overload their detector around the clock, and then making them dive so long that they will run out of air and fuel and forced to surface them. So by that time, they will drop the bomb and they will destroy them. So this was the first problem was solved by Patrick Blackett, and it was a super success because this submarine sinking probability, it went up from 2% to 45%. So it was a radical thinking. So that's why later he applied this war techniques in other problem as well, like resource allocation problem during World War II. And later he was awarded Nobel Prize for that. Nobel Prize. So that's why he is considered to be the father of operation research in England. But at the same time also, another scientist called Morse, Philip Morse in United States, he also working on operation research. And he was called father of operation research in the United States. So this is the story about operation research. So why it is called operations research? Because it was used to improve the military operations. That's why it is called operations research. So after the war was done, then operation research was used in government, business, healthcare, sports manufacturing, and beyond. So virtually it was applied almost in every industry. Okay, so now we'll see some overview about operation research. How can we define operation research or OR? Operation research abbreviated as OR. So OR is a discipline that deals with the application of advanced analytic methods to help make better decisions. When you have to make some decision with many alternatives and you have some limited constraints, limited resource constraint, then you have to apply operation research by using some advanced analytic methods like mathematical modeling, statistical modeling, mathematical optimization, and constraint optimization, like that. So next, what has strong ties to computer science and applied mathematics? Computer science because OR has to compute. In order to compute, computer is required. So that's why it has strong ties to computer science. And because it has algorithm also, and algorithm is very much close to computer science. Because all OR based on algorithm. And then algorithm computes the solution. And then mathematics. Then algorithm, to build an algorithm, you need mathematics. So mathematics here basically linear algebra and probability statistics. Sometimes operation research called as management science or decision science also. Then what is one important part? We can say that what is one important part of artificial intelligence as well. Because why it can be part of artificial intelligence? Because artificial intelligence, there will be two building blocks. One is not for all the problems. but most of the problem, like it will be machine learning, ML, and OR, operational research for optimization. So whatever thing you are forecasting or predicting, so that thing you have to analyze whether that prediction is benefiting or not. For example, Netflix. Netflix is recommending some videos to you. So there will be many alternatives videos that they can predict. But Netflix has to analyze whether that prediction is maximizing their profit or not. So in that case, they have to use operational research. So because nowadays operational research is applicable for every business and government organization. You already have seen that in military or air force, it can be applied in other field also, like railway and government owning railway. So in railway also, it is applicable. Even in politics, war can be applied. And this war is a very hot topic for academic research also now. So there is many areas like supply chain, manufacturing, transportation. So many topics are there, open topics. So next, we'll see what are the techniques of war. Yeah, if we talk about war, then first thing it comes like linear programming. What is linear programming? Linear programming is a very powerful tool when you have to maximize or minimize something, and you have some constraint. But you have objective function. That objective function need to be linear in nature, and your constraint also should be linear. So in that case, that will be linear programming. And the output or variables will be continuous variable. Like that variable can accept decimal points or fractional value it can take. Next is integer and mixed integer programming. So this is also very powerful nowadays because in many application area, the output required as integer variable, like how many product you are producing. So in that case, you are not producing 2.384, something like that. You are not producing. You are producing integer number like 5, 10, 50, 100. So in that case, you have to use integer or mixed integer programming problem. Why it is called mixed integer programming? Because in mixed integer programming, some variable it can take as continuous variable, and some variable can take integer. So that's why it is called mixed integer programming problem. And we can solve a mixed integer programming problem by branch and bound method, branch and cut method. Next, constraint programming. Constraint programming is like linear programming, but when you have a very complex system and you don't need optimum solution, but you need feasible solution. So in that case, you can use constraint programming. Sometimes it is called constraint satisfaction programming. Then I will see what is the game theory. Game theory also very powerful nowadays. So when we talk about game theory, then game theory can be classified into two categories. One is cooperative game theory, and another one is non-cooperative game theory. When we talk about non-cooperative game theory, like prisoner's dilemma. The best example is prisoner's dilemma. Like there will be two suspect, two suspect, and then they have some payoff while they kept in separate cell, and if they silence or if they confess, so there'll be different way of like if both confess, in that case for both 2 years jail, and if one confess, another silent, then in that case one who silent will be jailed for 10 years and another 1 year. So this type of payoff matrix you can formulate, and to solve this type of games, we can use Nash equilibrium. It is a very powerful algorithm. For that, John Nash got Nobel Prize. Then cooperative for Shapley was also Lloyd Shapley won Nobel Prize around very recently, around 2015, like that. Then Markov decision process. Markov decision process is like Markov chain. It follows Markov chain. Like the probability of any event will be only depending on previous event. So it is a memoryless property. So you don't have to remember all the past events, but only the previous event. And then simulation. When you have a very complex system, big complex system, and you want to imitate the system, then you have to use simulation. Like, for example, after COVID-19 is gone, then you have to check whether India is COVID free or not. So for that, you cannot check all the population. So you have to pick some population from every state. Then you have to set some probability. Like if probability is if 9.999, then if 1,000 people you have tested, then if 999 people don't have COVID, then it's like COVID free, and it will be across the state also. Across the state, you have to also check whether that probability is met or not. So this simulation also called Monte Carlo simulation. Okay, now we'll talk about some optimization tools. As I mentioned that optimization algorithm, optimization model, you have to build using computer. So for building optimization model, we have some ready-made tools where you can make optimization model, you can run model, and you can publish the solution. So Most popular optimization tool is IBM iLog Simplex. So IBM iLog Simplex is a very old optimization tools. Nowadays also it is very popular. And also IBM iLog Simplex has it can be used in different way. Like it has different languages like OPL, optimization programming language. It will provide you some UI, and there in that UI you can model your optimization problem. You can debug, you can run the model. And this simplex can be another application like .NET Concert technology. So .NET Concert technology, like in this case, you don't have to learn optimization OPL, optimization programming language. But if you know the object-oriented languages like C++, Java, .NET, or C++, you can integrate simplex to .NET or Java or C++, and then you can access simplex from your application, and you can model your problem and you can solve. So next is Groovy. It is similar like simplex, but nowadays Groovy claims that it has fastest solver. So Groovy also have similar functionality like simplex. They have concert technology. It can be integrated to C++, Java, C, Python, .NET, MATLAB, etc. Local solver is very new. So they have developed this solver around, I think, 2001 or something. So this is a local solver. So it has also optimization capability. And then we have FICO Express. But aims and jams are a little bit different. Aims and jams, they will give you some nice UI for designing your optimization model. And in aims, they don't have any optimization language, but you can integrate the simplex, Groovy, or local solver, or FICO Express here. So they will give you a nice UI to build the model, but the core optimization will be coming from these softwares. And Jam also similar like AIMS. And these all optimization tools are available for academic use. So for academic use, it is free. It is free of cost. But there will be some restriction of number of variables or number of constraints. So if interested, you can go ahead to install and use this tool Simplex Groovy. And even we can solve optimization problem in Excel. Excel has solver capability to solve optimization problem. And many more softwares are there. I have listed a few that is very popular. Okay, so now we'll see what are the applications of operational research. First of all, scheduling. Scheduling, we can use in many areas, many areas like your railway scheduling, aircraft scheduling, airlines scheduling. Then we have different application in manufacturing also. Manufacturing scheduling, production scheduling also we can use this. And then assignment. When we talk about assignment, then we know that job assignment we can do job machine. We have to assign some jobs to some machines. So job assignment is one of the application for assignment problem. And also timetabling. Timetabling means it could be university timetabling, like course timetabling or exam timetabling, or in industry employee timetabling also can be done by assignment. Let me drink some water. And then production planning. So we can see that production planning can be applied to manufacturing. So in the production planning, like capacity planning will be there, then resource acquisition is the application of production planning, and many more. And facility location. So in supply chain, facility location problem is very essential. You have to set up some warehouse, and from that warehouse you have some demand location. You have to satisfy some demand. So in order to locate some facility, you have some fixed cost. So the total cost will be minimized. Then shortest path problem. Shortest path problem is very popular in operation research. So it can be used in transportation shortest path problem. Then traveling salesman problem. So traveling salesman problem is also a very powerful algorithm. It can be used in vehicle routing problem, vehicle routing, and like school bus routing problem, and some traveling salesman problem can be applied to some you have to drill in some printed board. So basically, traveling salesman problem. So one salesman will be there. So they have to deliver some product to few cities and come back to his own city, so that he can travel each city only once. So these are the applications. And healthcare. In healthcare, like operation room scheduling problem is very popular, and also kidney exchange problem. Kidney exchange problem, like there will be some donor, there will be some receiver. So every donor cannot be matched with every receiver. So you have to match the kidney, so that optimally it can be distributed, optimally it can be assigned. Then like in a COVID scenario, we can apply operation research like for facility location for quarantine center, and a problem like when to initiate lockdown and when to release lockdown. And also now vaccines are coming, so in a vaccine allocation problem also processes can be used so that fair allocation can be done. Like if city A is getting this vaccine, then city B also should get that type of vaccine with the same priority. Okay, so now this is an example of linear programming model. So we have objective function that is linear, and we have linear constraint, and we have non-negative restriction. So from this model, we can see that the optimum solution will be x equal to 2 and y equal to 3. So that all the constraints will be satisfied. Right? If it is 3 and it is 2, it will be 5. And if it is 2 means 6 and it is 3, also 6. So 6, 6, 12. So it is satisfied and it will be maximized. You cannot get more Z value than this solution. So I'll interrupt you to show you something interesting here. Like if you have to apply this operation research optimization model in the industry, so I have two different models. It is taking some time. So you can see that I have got one small model and another one is large model. So the same model actually, whatever model I have shown just now. So that model is just 1 KB because it has only 2 variable and 2 constant. And I have another model where the size is huge, 1.3 gigabyte. So I'll show you the model. This is a small model, the model I have just shared with you. This is a very small model. And this is a very large model, 1.3 gigabyte. It has 75 lakhs of constraints and 71 lakhs of variables. Yeah, that's it. Okay, let me continue. Now we'll see what are the process of problem solving in industry. So first of all, when any optimization problem coming to you, then you have to first understand the business need, and you have to learn the domain knowledge first. Means you have to understand all the business requirement, what are the input data. You have to learn first, and then you can come up with the model development or design. Then after you understood all the business requirement, how they work, and what are the different kind of data you need to solve that problem. That is the first step. And then next step, model design. model design, you have to design your model then, and you have to verify by yourself whether this design works for you or not. Then you have to go to model development. You have to develop model by using your computer languages like C++, Java, or C#. You have to develop the model. Then you have to validate the model. Validate how? You have to unit test. Unit test by small data. There could be large data like the model I have shown just now, 1.3 GB. But to validate the model, you can just take small data. And if the model is already got validated, then you can deploy it for user acceptance testing. Because ultimately, whatever model you have created and whatever model you have developed, that will be used by your user. So then user acceptance testing will be done. If user accept that model, that there will be no problem, no issue, then you can deploy the model in the production for their use. Then if you deploy the model, that is not the end of the story. You have to support and you have to maintain the model. Like sometimes what happens while running the model by user, the model can be infeasible. Sometimes data is not coming, so model will be infeasible, or maybe sometimes user updated wrong data. So that's why also you are getting unbounded solution or infeasible model. So in that case, you have to support. And you have to maintain the model also, because initially you have created the model. So gradually it will be bigger. Like some requirement, it will be gradually coming. So you have to maintain the model also. You have to add some constraints, some variables, some requirement, some pre-processing, some post-processing. You have to add. So you have to maintain that. So this is the problem solving processes for optimization. Okay, so now we'll see some advanced algorithm for OR. So these are very advanced. Like in academic stage, you will not be using this algorithm for just for sharing. The branch and bound and branch and cut maybe you can use for solving integer programming problem. But this four is very high level algorithm. It can be used for very complex and very large problem. So like column generation. What is column generation? So when like now I have shared that in my large model we have 71 lakhs of variables. What about you have billions of variables? Billions means 100 crores of variables. Then your computer cannot solve it, cannot handle it, because your memory, all memory will be eaten. So you cannot solve by your computer. So you have to use column generation. Column generation is a technique. It will be starting with a small subset of variables, and then by iteratively you have to add those variables which will be coming into the final solution. Like if you have 100 variables and you have 10 constraints, so in the final solution, the variable with non-negative value will be only 10, and rest 90 variables are useless actually. So in column generation, you have to eliminate the useless variables. Then the branch and price. Branch and price also is kind of column generation, but it can be used. It is used only for integer programming problem. Then tangible decomposition. Tangible decomposition, like when you have a problem, like you have a block structure shape. You have problem like block structure, like you have this kind of your matrix structure will be like this. So means you can decompose the whole solution, whole problem into smaller problem, and you can solve. But here also ultimately you are using column generation. Then Bender's decomposition. Bender's decomposition is only used for solving mixed integer programming problem. When you have variables, like you have n plus m variable, so and n your n number of variables can take continuous value, and m number of variable can take integer value. Then we should use Bender's decomposition. Okay, so now I'll discuss some application of OR in airlines industry. So this is this problem I have selected because this is very interesting problem. I hope you will also interest. So this is a typical airline problem. So there will be some steps of airline problem. Like first, evaluate the market demand. You have to, they have to, airline has to evaluate the market demand. Like if they are flying one flight from Bombay to Delhi, then they have to evaluate the demand of that particular flight. So whatever flight they have planned, they have to evaluate all flights demand. Then they have to determine the flight schedule. So whatever flight they have planned, they have to come up with the timing. What is the departure time? What is the arrival time of that particular flight for all flight? Then assign fleets to flight. Then you have to assign fleets. So fleets basically there could be different types of fleets. Like for Airbus, A320, A319, A330, A380 also there, and Boeing has 737, 738, 777. and also like small capacity fleets like Q400 Bombardier. So you have to assign the different type of fleet depending on the capacity and the demand. If the demand is very less, then you have to assign Q400 Bombardier. And if the demand is very high, either you have to assign Airbus A380 or Boeing 737, 777, like that. Then we have to optimize crew schedule. The airline has to know what is the minimum number of crew required to fly all the flight of the timetable or the flight timetable. Then finally, they have to generate and assign bid lines. Bid lines means some duties will be assigned to a particular crew member. So it is based on seniority also. So senior will get the most preference. So this is about airline problem. So different type of airline scheduling are called crew pairing problem, crew rostering problem, aircraft routing problem, tail assignment problem. Crew pairing, like you have a set of flight and you have a set of crew. So you have to determine what is the minimum number of crew required to fly all the flights for the flight timetable, so that the total crew cost is minimized. Then crew rostering problem. You have to assign each crew to a pairing. So that is called crew rostering problem. So that the crew quality of life is maintained. Then aircraft routing problem. For each of the aircraft, you have to route, like that particular aircraft will be flying which flights. So all the sequence of flight, it should be assigned to that aircraft. So that is aircraft routing problem. And tail assignment problem. Like, once crew pairing and crew rostering is done on the day of flight or before day of flight, a particular aircraft has to assign to a flight. Like you have A320. A320, you have total 10 flights, 10 aircraft. So among the 10 aircraft, which aircraft is going to fly the flight from Ahmedabad to Mumbai? So that is called the tail assignment problem. So today I'll elaborate and discuss about a crew pairing problem. So in order to learn crew pairing problem, you have to know or understand some terminologies like duties, trips or pairing, crew bases, layover bases, and deadheads. So duty. What is duty? Duty can be any task that crew member required to perform, including it can be flight duty or admin work or training. While his training also can be part of duty. And while positioning, we'll see later what is positioning or standby. If any crew is standby, so that means he is performing his duty. Then trips or pairing. What is the trips pairing? The trips on pairing actually you can say the series of duties, or because duty can be a series of flights. So here series of flights with first flight departure and last flight arrival at same crew base. Like we can say that it is a trips are pairing. If one crew is going from, let's say, from Mumbai to Ahmedabad, Ahmedabad to Hyderabad, Hyderabad to again Mumbai. So he has started from Mumbai and he come back to Mumbai. So that is pairing. So that's why the first flight departure and last flight arrival same crew base. And now what is the crew base? Crew base is the city where the crew is domiciled, his home city. His home city will be the crew base. So every airlines has a few crew bases where the flight frequency is bigger. Like the crew bases will be Mumbai, Delhi, Hyderabad, Bangalore, Chennai, sometimes Ahmedabad also, Kolkata, and layover bases. So after each duty, it is not necessarily that crew member will come back to his crew base. Sometimes he has to layover, like he has to take overnight rest at a designated base. Like one flight is going from Mumbai to Kuala Lumpur, then Qatar, Dubai. So then his duty time is already over. So that's why he has to rest as per government law or regulatory body law. He has to rest. Then the next day he has to take another flight. Then like from Dubai to Mumbai, he can come back. So that will be layover. So overnight rest should be given. That is called layover. So airlines has some particular layover bases. Like all the bases are not layover bases. Some only designated bases due to they want to minimize their layover cost. Then deadhead. Deadhead concept is like if one crew base is Mumbai and he has to take flight from Bangalore, then he is not operating any flight from Mumbai to Bangalore, but he is coming as passenger. He is coming as passenger, deadhead. So head count will be 0. So it is called positioning. So we are positioning crew from Mumbai to Bangalore. Okay. So objective of crew scheduling is like crew cost being the second highest cost after fuel cost. So every airlines would like to know what is the minimum number of crew required to operate a flight timetable. This is the scenario where in the middle they have statutory regulations and government laws, and at the same time they want to minimize their crew cost, and they want to maximize the crew quality of life. So it is both good because when we are talking about crew quality of life, so we are talking about like layover basis, how many layover you are giving to one particular crew, how many aircraft changes he is doing, how many what is the waiting time. So if one crew has to wait long time, so that means his quality of life is not good. So we have to both we have to minimize in this case. So uh, at the same time, we have to minimize both. We have to balance them. We have to balance like this: crew cost and quality of life. And this is like some FDTL rules, so flight duty time regulation rule, maximum flight time here. So if one flight is operated by two pilots, then the maximum number of landings, what is the maximum number of landings? So up to six landing, he can do 8 hours of flight time. If the number of landing is less than less like up to three, then 9 hours. Then if more than three, up to six is 8 hours. 8 hours he can do the flight time. For night operation only he can do two landings. Like night operation like night 10 p.m. to morning 6 p.m. 6 a.m. That is the night operation. For night operation, he can do 9 hours up to two landings. Two landings only he can do. So we have to optimize with while we are keeping all these rules and regulations. And this is for domestic and this is for international. The international, 10 hours up to one landing. For day operation, 9 hours up to three landings. For night operation, 9 hours up to two landings. This is for two pilot operation. Sometimes in international flight, three pilots or four pilots operations are also there. So if it is three pilot operation, then one pilot can do 12 hours of flight time while he is doing one landing. And while four pilot operation, 16 hours for and one landing. And four pilot, you will have ultra long range operation. If it is while flight going from India to the United States, so we have more than 16 hours of flight. So that is called ultra long range flight. And this is some rule related to flight duty time. The duty time, why the flight time and flight duty time is different? Because there will be some gap between two flights. Like as I said, if one crew is coming from Mumbai to Hyderabad, and he has to take another flight from Hyderabad to Chennai, so there will be some time gap between the flight. So that time gap, so-called transit time, included in the flight duty period. The maximum daily flight duty period limitation is 12.5 hours. And two landings for night operation and three for day operation. And maximum flight time limitation is 9 hours, as we have seen in the previous file. And 12 hours for four landings. 11.5 hours for five landings. 11 hours for 6 landing. And the flight time limitation is 8 hours. And here you can see some reduction of flight duty period due to operation in WOCL. WOCL means window of circadian loop, meaning while you are while any crew is flying night time from 2 to 6, midnight to 2 a.m. to 6 a.m. So that is called WOCL time. So that time your flight time will be reduced. So now I have an example. We have 2 days, and these are the flights. So first, and we have 2 aircraft because 2 lines means 2 aircrafts. And this flight is going from Delhi to Bombay, Bombay to Delhi, and Delhi to IXA, IXA to Delhi, Delhi to Bombay, Bombay to Delhi. And the second aircraft is going Bombay to Ahmedabad, Ahmedabad to Bombay, Bombay to Bangalore, Bangalore to Bombay. And it is repeating every day. So, crew pairing optimization concept is here. We are using 2 aircraft and 10 flights per day. And where we have given layover cost is 10,000 per night. And while crew cost is 50,000 per working day. That is, that may include crew salary, then transportation costs, some other allowance. So this is the data. Then we have to see what is the optimum crew pairing. So we have 2 cases, and we have crew quality of life considered. So in first case, every crew returns home the same day. So one crew is going from Delhi to Bombay, Bombay to Delhi, Delhi to IXA, IXA to Delhi. So Delhi to Delhi is coming back on the same day. And here also Delhi to Delhi is coming back. And here Bombay to Bombay is coming back. And here what is the number of crew we are utilizing is 3. And another case, every crew can do 1 layover. So layover means he has to take a rest in some layover basis. Okay, so here it is coming from Delhi to Bombay, then Bombay to Delhi, Delhi to IXA, IXA to Delhi, then Delhi to Bombay. Then he has to do some layover here. He has to take rest here in a hotel. Then he is doing the second day duty. Bombay to Ahmedabad, Ahmedabad to Bombay, Bombay to Bangalore, Bangalore to Bombay, and Bombay to Delhi. And the second crew also, Bombay to Ahmedabad, Ahmedabad to Bombay, Bombay to Bangalore, Bangalore to Bombay, Bombay to Delhi. Then he is doing layover here. The next day, he is taking this series of flights and come back to Bombay. So he has started from Bombay, coming back to Bombay next day. And here he has started from Delhi and coming back to Delhi. And next page, we can see the result comparison. In the first case, we have not used any layover, while we are using 3 crews per day and total 2 days. So total is 6 crews. So 6 crews True cost was 50,000. So here it is 3 lakh. In the second case, because we have used layover, then let's see what is the total cost. So 2 crews per day, 2 days, 4 crew, 2 lakhs. Then 2 layover, 20,000, 2 lakh 20,000. So here we're getting less cost than this scenario. So in the optimum solution, we need to get this kind of solution so that the total cost will be minimized. Then this is the typical model for group pairing problem. This is the mathematical model, but it looks like very simple, but it is not as simple as it looks. While solving group pairing problem, the number of variables can go up to millions. 10 lakhs, 20 lakhs, 30 lakhs, 40 lakhs of variable concern because they have so many flights to operate. And this is the this is the number of pairing we have generated, and AIP is the coefficient of the XP. If XP is selected, then AIP is if this pairing P is operating flight I. In that case, AIP will be 1, otherwise 0. So this is flight coverage constraint. Whether this pairing is covering this particular flight or not. So this is flight coverage constraint. And another type of constraint will be global constraint, like for each crew basis, how many crews are available? Like in Bombay, J is location, like Bombay, Delhi, Ahmedabad. They have three crew bases. So let's say for Bombay, 100 crew available, Delhi, 70 crew available, Ahmedabad, 50 crews available. So this is the global constraint, crew availability constraint. And how many in this particular pairing, how many crews we are using? That will be BJP. So this is a typical model for crew pairing. This is also very hardest problem to solve because this is integer programming problem. Integer programming problem always hard to solve. The next CPP algorithm, crew pairing problem algorithm. The problem solving process is like this. First, you have to fetch all the data, all the flight data, all the regulations data, flight duty time, flight time, and also other settings like what is the length of the pairing, what is the length of the duty, or what is the maximum number of flight it should be in a duty. So many other settings also you have to fetch. Then you have to generate flight connection, the connection between two flights. You have to generate the connection. Then there will be some illegal connection, like connection time is very large or connection time is very small. Like the flight connection could be 10 minutes, could be 2 hours. So 2 hours is very long. So maximum maybe 1 hour and minimum will be 30 minutes. So all the illegal flight connection, you have to delete. Then based on the whatever legal flight connection you have generated, you have to generate duties. So you have to connect all the flight connection to make duties. And here you have to run the legality engine or rules engine, so that it can delete all the illegal duties. Like some duties, it can violate total flight time or number of flight of that duty. It can violate. So this algorithm will delete those illegal duties. Then, based on the whatever duties we have created, we have to create all the pairings. And here also you have to run the legality engines or rules engine. And you have to delete illegal pairings. And you have to build the optimization model with all the legal pairing and solve the model, then publish the result. So this is the algorithm.
Amit sir?
Yes.
Yes, we're having few questions, so I think...
Yeah, we'll take a question after I complete.
Okay, fine.
Okay. Let me complete and I'll take a question. Okay, so I'll quickly go through. What are the sources of complexity of this model? So source complexity can be come from different parameter, like number of trips or pairing generated. Because if number of trips means number of variables, if number of variables went up to billion, then there could be problem. You cannot. It will be very difficult to solve that problem. And the number of flights in the timetable. If number of flight is very high, then it will be a complex problem. Then number of layover bases. If number of layover bases are more, means the chance of creating more number of pairing. So that means the more number of variable will be generated. Similar for number of crew bases and a number of aircrafts. Because if you have more number of aircrafts, then aircraft change will be there. So in that case also, it has more opportunity to pair with other aircraft, and eventually it will create more number of pairing. And also FDTL rules, like maximum flight time limitation. If the maximum flight limit is less, in that case, less number of pairing will be generated. If the numbers, the limit is more, then more number of pairing will be generated. So in that case, because it is MIP problem, mixed integer programming problem, so it will be difficult to solve. So the model will be complex. Okay, I'll introduce you another manufacturing problem where we can apply OR. Like this is LED. Let's say one LED manufacturing company produce LED. And for LED, there are three main parameters. One is flux, and another one is voltage, and another one is color. So problem description is like millions of inventories that is not shipped, because every time new product is coming, there will be some uh, out of specification product, and that cannot be shipped, and that will be placed in the inventory. So our objective is to utilize those excess inventory via kitting orders. So that's why it is called kitting pattern optimization. Kitting means just packaging. You have to package with a combination of product and minimize the future inventory build. So you have to remember that three main parameter: flux. Flux means flux controls the brightness, voltage control voltage, and color, different color. So this three parameters. So heating concept is like that. When company is producing LED, it is not necessarily they will produce all the product within a specification. It is very difficult in semiconductor industry to create to produce all the spec within a specification. So some product will be less than specification, and some product will be high. So here I have used orange analogy to make you understand what is the kitting. So let's say we have orange that is meeting the user requirement, and that orange that is within the specification. So that's why within the specification we can just directly sell to customer, because that is their requirement. And some will be too sour and some will be too sweet. So then how we'll do with that too sour and too sweet oranges? So you can make a juice with too sour and too sweet oranges to make in-spec juice, like whatever sweetness you need, that you can produce by mixing these too sweet and too sour oranges, and you can make the in-spec product. So that is the kitting concept basically. So you have to produce one product, combine all the out of spec product to make it in spec product. So here is the concept. While testing is done in the semiconductor industry, they used to create binning for each of the product. Like they're producing LED light whose flux range is like let's say 100 to 200. So if 100 to 120, they are binning like 8A. And if 120 to 140, they are binning 8B. If 140 to 160, they are binning 8C and so on. So they bin in different bin. Different bin they can bin. So they can have some number of binning. Like here you can see 1, 2, 3, 4, 5, 6. So total 12 bin here. And they have to create one product which is having 3 LED, which is containing 3 LED to make this product. So they have to pick 3 from these bins. So how manually, how do they know that if I pick from this, then specification will be met? So they cannot manually do that. So they use optimization model to decide which bin they have to pick. That this, that. So here also, if 3 bin here, three slot here, and you have 12 bins. So number of combination will be very high. So it will be like 3 to the power 12. So with this combination, we have to optimize and we have to make decision. What are the pattern? What are the pattern you want to pick? Like 8E, 8B, 7C is one pattern.